Hi guys, let's try this again. This is Unit 4, Section 1. We're talking about quadratics. Just know that this is the standard form for the quadratic function. So ax squared, bx, and c is the constant. A cannot be 0 because that would mean that the x squared wouldn't be there. So then leaving you with just bx plus c, that would be a linear function. That's why there's the restriction there that a cannot be 0. But this is the standard form for the quadratic function. So in here we have our parent function, and we can come up with the table just by substituting the x values right there and squaring them. So I have -3 squared, I get 9, -2 squared, I get 4, and so on. So -1 squared is 1, and that's how I was able to complete that table. Now we have the x-intercepts. The x-intercepts are, or is in this case, because it's the parent function, we have only one in this case. That's where the graph crosses the x-axis. This is the x-axis, and it crosses right there at the origin. That's why this one in particular is right there at 0, 0, because it's at the origin. So the y-intercept, that's where your graph crosses the y-axis. The y-axis is right there. It crosses right there at the origin again. Now the axis of symmetry, that's this orange dotted line right there. That's the vertical line that cuts that parabola right in the middle, right in half. So the axis of symmetry. Just so you know that this part is a reflection over that part, and they're exactly the same. But the axis of symmetry goes through the vertex always. And because it's a line, you need that x equals the x from the vertex right there. The vertex of the parent function is right there at 0, 0. The domain for all quadratic functions is always all real numbers, or from -infinity up to +infinity. And that we're not talking applications or anything, but the default is that the domain is all real numbers. Now the range is all the y values, starting from here, right there at 0, and going all the way up toward +infinity. So you can write this as inequality or interval notation. It's inclusive because 0 actually is part of your range. And you know the shape of a quadratic function is a parabola, or the U shape, but the proper name is a parabola. Here I tried to color code what the items are. So here I used purple to mark the x-intercepts. So the x-intercepts are the 2 points that cross the x-axis. In this case, I have the 1, 0 and the 5, 0. Then I used green to mark the y-intercept, and the y-intercept, that's the point where it crosses the y-axis, and it crosses the y-axis right there at 0, 5. The axis of symmetry, that's the line or the vertical line that goes through the origin right there, and it cuts your parabola in half. And because it's the vertical line, it's an x equals, and it's the x of the vertex. So x equals 3 right there. Now the vertex is that point right there in blue, that point at 3, -4. And from the previous page, the domain is all real numbers for all the parabolas and all the quadratic functions, or in interval notation, from -infinity to +infinity. The range in this case is all the y values starting right there from -4 and going toward +infinity. So, and it's -4 inclusive. Same idea we have here for the next example. I filled out the table partially by pulling the y values from the graph, but notice how -3, the graph is not there. So I can actually see what my y value would be in this case. So the second way, or a different way that you can come up with the y value here, is by substituting -3 value right there for x and right there for x. And that's what I did here. I showed my work all pretty. So negative 3 squared, that's positive 9. Negative 2 times negative 3 is positive 6. So 9 plus 6 is 15. And then minus 3, that's 12. That's how I got 12 there. And then to complete filling out the table, I pull the y values from the graph. So negative 2, 5 right there. Negative 1, 0, and so on. Now, x-intercepts, I have these 2 points. And I know the x-intercepts, they have the y values as 0. And then I have the y-intercept. Y-intercept is right there, where the x value is 0. That right there. Then I have the vertex, is that blue point right there. And then the axis of symmetry is that vertical line that cuts the parabola right in the middle. And it's a vertical line, so it's a x equals the x from the vertex. Axis of symmetry. Okay. So now I'm going to try to fill out the table from the information I have from the graph. So negative 3 is right there. So negative 3, 0. Negative 2, 3. Negative 1, 4. 0, 3. 1, 0 right there. 2, that's negative 5. And 3 will be the one that it's out of the graph. But I know that I can just substitute that 3 value right there for x. So negative 3 squared minus 2, substitute 3 for x, plus 3. Then you can punch it in the calculator, but I think it's just easier just to do mentally. So here I have negative 9 minus 6, that's negative 15, plus 3, that's negative 12. Okay, so now we're going to use purple for the x-intercepts. And I know that the x-intercepts, they have the y values as 0. So x-intercept right there. And then the y-intercept, that's the point on the graph where it intersects the y-axis. And I know the x value for the y-intercept is 0. So y-intercept right there. And next, we can do the vertex. The vertex is that point right there. And that one is negative 1, 4. So vertex. Okay. The axis of symmetry will cut your parabola right there in the middle. And because it's a vertical line, you have to write it as x equals then the x of the vertex. So x equals negative 1. That's your axis of symmetry. Number 3. Let's fill out the table. So negative 3. Notice how it's going by halves over here, okay? So negative 3 is right there at negative 1. Negative 2 is right there at 0. Negative 1, negative 1, 0, negative 4. 1 is right there off the graph. And same thing will happen to 2 and 3. So we need to do those by hand. So negative, I'm going to substitute 1 right there for x. So 1 plus 2 squared. 1 plus 2 is 3. 3 squared is 9. And then you have that negative. So negative 9. Same thing for 2. I'm substituting 2 right there for that x. 2 plus 2 is 4. 4 squared is 16. And then you have that negative right there. So negative 16. Same thing for 3. Substitute 3 for that x right there. So I have 3 plus 2 is 5. 5 squared is 25. And that negative, that makes negative 25. Okay, so x-intercept will be right there. So x-intercept right there. And then I have y-intercept right there where the x value is 0. So y-intercept. Then I have the vertex, which is also the x-intercept. So vertex right there. The x is a symmetry. That's that vertical line that cuts your parabola right in the middle. And because it's a line, it's x equals. So x equals the x from the vertex, which is -2 right there. And then I'll start a new video with the following pages.